Voyager is sending back terrifying data to Earth. NASA's Voyager 1, the farthest traveled space device, is currently journeying across hidden regions of the universe, nearly 50 years after its launch. Scientists are puzzled by the disturbing data this remarkable spacecraft is sending back to Earth, as it seems to indicate some kind of malfunction. We will explore the strange data Voyager has been transmitting during its ongoing mission. Scientists have long been interested in understanding the history of space since the Big Bang, which inspired the launch of the Voyager missions. Voyager 2 was actually the first space probe launched, departing from NASA's Kennedy Space Center on August 21, 1977. Just 2 weeks later, Voyager 1 was launched. Despite being twins, the two probes were placed on different trajectories. Both spacecraft weighed about 720 kilograms, roughly the size of a small car, and were launched during a rare window of planetary alignment that allowed for slingshot maneuvers, using gravity to accelerate them from one planet to the next. Although they started their journeys in the same direction, Voyager 1 eventually surpassed its twin. On December 15, 1977, Voyager 1 passed Voyager 2 and has since become the go-to probe for studying distant regions of space. Voyager 1's mission began in earnest in 1978 with its Jovian imaging mission. By this point, the spacecraft was about 265 million kilometers from Earth. It sent back a vast number of photographs, including a remarkable 100-hour stretch starting in January 1979, capturing 3,750 images of Jupiter's rotation. Voyager 1 also documented Jupiter's moons, including discovering 2 new ones, Gangster and M. The probe continued its exploration of Saturn, identifying new moons such as Mimas, Enceladus, and Dione. After completing its planetary mission, Voyager 1 and 2 were both sent beyond our solar system, traveling at a speed of 325 million miles per year. In January 1990, the Voyager interstellar mission began. It was during this phase that Voyager 1 captured some of the most iconic photographs in space exploration history, including the family portrait of the solar system, taken on February 14, 1990, when Voyager 1 was about 6 billion kilometers from the Sun. These photos, 60 in total, included all the planets in our solar system, although Mercury and Mars were not visible for various reasons. In 1998, Voyager 1 passed the previous record holder, Pioneer 10, as the farthest spacecraft from Earth. It continued its journey through space for another 14 years, eventually reaching the interstellar medium on August 25, 2012. However, NASA did not officially announce this achievement until 2013. As of November 2008, both Voyager 1 and 2 had officially exited the solar system. Voyager 1 was measured to be approximately 145 billion miles, or about 1,550 light-years, from Earth. Since then, the probe has continued to send us vital data that no other space mission has been able to provide. For most of its 45-year journey, the spacecraft has remained in good health, but recently, scientists have noticed some strange anomalies in its performance. Voyager 1 is currently sending puzzling signals back to Earth that suggest it is unsure of its position. However, there is a troubling twist. Typically, NASA has programmed Voyager to enter safe mode or send out an alert if it experiences a malfunction in space. Despite the odd readings, the spacecraft's radio antenna, which transmits data back to Earth, appears to be in working order. However, the data it has been sending is perplexing, and the usual communication and control systems are not fully aligned with the current state of the spacecraft. Voyager 1, like all space probes, carries a golden plaque containing a variety of messages and images as a backup, in case an extraterrestrial species happens to find the spacecraft. The plaque contains 35 sounds from Earth, 115 images of life on our planet, an hour and a half of Western music, and messages from former U.S. President Jimmy Carter and UN Secretary General Kurt Waldheim. The information on the golden disk is stored in 55 languages, so if the spacecraft is ever discovered, alien beings might attempt to decode it. While some have speculated that the spacecraft could be under the control of extraterrestrials, scientists have quickly dismissed these ideas. The ability of the Voyager spacecraft to function depends heavily on its attitude and direction control systems. These systems ensure that its radio antenna remains pointed toward Earth for data transmission, and that the spacecraft maintains its proper orientation. Experts believe that Voyager is still functioning as intended, which only deepens the mystery. As of now, none of the spacecraft's safety protocols have been triggered. However, scientists are still investigating what might be causing these oddities. Both Voyager probes are now over 45 years old, which is far beyond their original expected lifespan. As a result, the engineering team is facing a range of technical challenges in trying to resolve the issue, especially considering the vast distance between Earth and Voyager 1. The enormous distance between Earth and Voyager 1, which is approximately 145 billion miles away, presents significant hurdles. Communication signals from Earth take about 21 hours to reach Voyager, meaning that any commands or instructions sent from Earth will require a full day to be received. Once Voyager responds, it takes another 21 hours for the data to return, creating a 2-day delay in communication. This lengthy delay complicates the process of troubleshooting and solving the technical issues with the spacecraft, as specialists cannot immediately respond to or adjust their instructions. In addition to the communication delay, the technology on Voyager 1 is now considered obsolete, as it was designed and built in the 1970s. The spacecraft is also subjected to harsh conditions in space, including radiation, extreme temperatures, and micrometeoroid impacts, all of which have contributed to wear and tear on its systems. Despite these challenges, the engineering team is determined to resolve the issues, conducting experiments and simulations on Earth to test potential solutions. The team is also exploring the redundancy built into the spacecraft systems. Voyager 1 was designed with backup systems to increase its resilience in case of failure. The engineering team hopes to use these systems or reconfigure existing components to mitigate the issues. However, until the exact cause of the anomaly is understood, it is difficult to predict how long Voyager will be able to continue gathering and transmitting scientific data. Despite these challenges, NASA remains optimistic. Susan D., the mission's chief, has expressed confidence that if the issue is related to the attitude control system, which manages the spacecraft's orientation and communication, it may be fixable. Voyager 1's incredible journey has brought it to the farthest reaches of our solar system and beyond, into interstellar space. As it continues its voyage farther away from Earth, it remains a testament to the ingenuity and perseverance of human space exploration. The extraordinary journey of Voyager 1 offers a unique window into the vast and largely unexplored reaches of space. As it continues to travel farther from our solar system, Voyager 1 becomes increasingly valuable in our efforts to understand the universe beyond the familiar confines of our cosmic neighborhood. The data it sends back is more than just a record of its mission. It serves as a signal of human ambition, reaching into the farthest corners of space, beyond the influence of our sun. Voyager 1's achievements have been monumental, providing unparalleled insights into the outer reaches of our solar system and interstellar space. However, with each passing year, the distance between Voyager 1 and Earth continues to grow, and the technical challenges of maintaining communication with such a far-flung spacecraft multiply. While the spacecraft's primary scientific objectives have already been completed, its ongoing journey is proving to be a treasure trove of data that could take decades to fully analyze and interpret. As Voyager 1 moves deeper into interstellar space, it will continue to make groundbreaking observations. One of the key aspects of the probe's current mission is its ability to measure the characteristics of the interstellar medium, the gas and dust that exists between the stars in our galaxy. Scientists hope that the data from Voyager 1 will help to refine our understanding of the structure and behavior of the space that lies between the stars, a region that is not easily accessible by other means. Moreover, Voyager 1's instrumentation is also monitoring cosmic rays, which are high-energy particles that come from outside our solar system. These particles travel at nearly the speed of light and are of great interest to scientists studying the solar wind, galactic winds, and cosmic radiation. The measurements of cosmic rays collected by Voyager 1 are particularly valuable because they offer a glimpse into the conditions of space beyond the protective bubble created by our sun's magnetic field. The data on these cosmic rays could potentially provide insights into the fundamental nature of the universe and the behavior of matter in deep space. One of the fascinating elements of Voyager 1's ongoing journey is that it is now encountering a very different environment than it did in the outer reaches of our solar system. As it enters interstellar space, the spacecraft is no longer affected by the solar wind, the continuous stream of charged particles emitted by the sun. This shift marks a dramatic change in the probe's surroundings. In the solar system, the solar wind interacts with the charged particles in the space around us, creating a bubble-like region known as the heliosphere. However, as Voyager 1 crosses the boundary of the heliosphere, it enters the void of interstellar space, where the environment is vastly different. The difference between the two regions is profound, as the interstellar medium is composed of much lower density gas and particles, as well as more intense cosmic radiation. Scientists are eager to understand how the transition from the heliosphere to interstellar space will affect the behavior of the spacecraft and the data it sends back to Earth. While Voyager 1 is still able to send back valuable data, it is increasingly operating in a more difficult environment. As the spacecraft continues its journey, its power supply will gradually diminish. Voyager 1 is powered by a set of radioactive thermoelectric generators, which convert the heat produced by the decay of plutonium into electrical power. These generators have been remarkably efficient, allowing Voyager 1 to continue operating long after its expected lifespan. However, the amount of power available for its instruments and systems will inevitably decrease over time as the plutonium in the generators continues to decay. Eventually, the spacecraft will be unable to power its scientific instruments or communication systems, signaling the end of its mission. Although this is not expected to occur for several more years, it is a reminder of the limitations inherent in space exploration. As Voyager 1's power supply diminishes, NASA's engineering team will have to make difficult decisions about which systems to prioritize. For example, the spacecraft's scientific instruments may be powered down in order to conserve energy for communication with Earth. Given the long communication delays, maintaining the ability to receive commands and transmit data will likely be the highest priority. In the final years of its mission, Voyager may first be able to continue transmitting basic data on its status, but its ability to perform complex scientific observations may be limited. Despite these challenges, the sense of awe and wonder surrounding Voyager 1's mission persists. Its voyage serves as a testament to human perseverance and ingenuity, and it continues to inspire the next generation of scientists, engineers, and explorers. The probe's scientific legacy will endure long after its mission comes to an end, with its data continuing to inform research in fields ranging from astrophysics to space exploration. In many ways, Voyager 1 is a symbol of the human drive to push the boundaries of knowledge. Its launch in 1977 marked a milestone in space exploration, and its continued success has been a source of inspiration for subsequent missions. The lessons learned from Voyager 1's journey will undoubtedly shape future space missions, both within our solar system and beyond. The probe's ability to communicate over such vast distances has demonstrated the power of technology to bridge the gap between distant worlds, and its scientific discoveries have deepened our understanding of the cosmos. Looking forward, there are plans for new space missions that will build upon the foundation laid by Voyager 1. For example, NASA's upcoming missions to study asteroids, comets, and the outer planets will use many of the same technological principles that were pioneered by Voyager. However, these future missions will benefit from advancements in technology, such as more powerful communication systems and more efficient power sources, which will help overcome some of the challenges faced by Voyager 1. In the meantime, Voyager 1 will continue to send back valuable data from the farthest reaches of space. The spacecraft is expected to remain operational for several more years, providing unique insights into the interstellar medium and cosmic phenomena that cannot be observed from Earth. While its power supply will eventually run out, the spacecraft's remarkable journey will have made a lasting contribution to our understanding of the universe, offering a glimpse into the distant future of space exploration. For now, Voyager 1 remains the farthest human-made object from Earth, a silent sentinel traveling deeper into the unknown, carrying with it the hopes and dreams of humanity's quest to explore the stars. Voyager 1's journey is not only about the scientific discoveries it has made, but also about the enduring human spirit of exploration. It represents a bold leap into the unknown, embodying the ambition of sending a message across space, an effort to reach out beyond the confines of Earth and touch the stars. The spacecraft carries with it a golden record containing a variety of cultural and scientific information. This time capsule was designed as a representation of humanity, a message to potential extraterrestrial civilizations that may encounter the probe long after its primary mission ends. The inclusion of sounds and images of Earth, from greetings in multiple languages to music from different cultures, provides a snapshot of life on our planet. Voyager 1's mission thus becomes not only a scientific one but also a symbolic act of connection, an offering of humanity to the cosmos. As Voyager 1 continues to drift through interstellar space, it serves as an important milestone in the evolution of space exploration. The data it provides is invaluable to scientists who are striving to understand the complex and dynamic environment beyond our solar system. The information gathered by Voyager 1 will help shape our understanding of interstellar space for years to come, but it also raises new questions. One of the most intriguing aspects of the probe's ongoing mission is how it will continue to measure the boundaries of our solar system's influence. The heliosphere, the bubble of charged particles emitted by the Sun, has long defined the extent of our solar system's reach. As Voyager 1 moves deeper into interstellar space, scientists are eager to learn how the solar wind and magnetic fields interact with the surrounding medium, and how far the Sun's influence truly extends. In the coming decades, Voyager 1 will continue to push the boundaries of human knowledge. Even as it reaches the limits of its power, its legacy will remain intact. The spacecraft will eventually fall silent, but the information it has sent back will continue to inform scientific research for many years. The scientific community is already analyzing data from Voyager 1 to study the properties of interstellar space, from cosmic radiation levels to the behavior of the plasma that surrounds it. While other space missions will follow in the footsteps of Voyager 1, none will match its symbolic significance as the first spacecraft to cross into interstellar space. In addition to its scientific contributions, Voyager 1's long journey raises important questions about the future of space exploration. The challenges of communication and maintenance that the spacecraft faces are likely to become more common as humanity begins to send more probes farther into the galaxy. The lessons learned from Voyager 1's operation, particularly with regard to managing long-distance communication, energy limitations, and system reliability, will be crucial for the success of future missions. As our ambitions grow to explore planets in other star systems, these same lessons will guide the development of next-generation spacecraft.